Okay, so yeah, the steps. So we'll go over the steps. We'll go over everything, but I just want to go over. So the reason we do a confidence interval, the reason we do a confidence interval is for the same reason you guys with the pennies, right? The pennies, when you guys did the pennies, right? We're trying to get to the answer, the true number of pennies in the jar, right? And you guys said, "Hey, I have a guess, but I'm not very confident about it." Right? And then we talked about how would my level of confidence go up if I give you an interval, right? And then the bigger the interval, the more confidence you would get, right? That's what a confidence interval is. How confident are you that your interval contains the true answer? Okay, so here are the parts of the confidence interval that we did yesterday. So just to repeat over the question, right? An owner, what is the answer we want to find? Well, the owner of a popular chain of restaurants wants to know if meals, right? Meals are getting to the customer within a minute. He or she wants to know the true percentage of meals that are getting to the customers within 1 minute. Okay, they want to know the true percentage. So they take a sample of 75, right? Take a sample of 75. Out of those 75, 60 of them get to the minute. So about 80%, right? So our true proportion, P is going to represent, we don't have P, but it's going to represent the true proportion of all meals that reach the customers within 1 minute. Okay. This is the equation we're going to use, right? P hat is our point estimate, right? Because sometimes they say, find the point estimate. What is that? That's based off the sample. What was the sample proportion? Okay. Z critical comes from our table, right? Our table that we did yesterday based off of the Z scores, right? Okay. And then the last part is it's called the standard error of the mean. That's the title of it. It's just the standard deviation of the statistic. We used it last semester. We used it last chapter, I should say. First chapter of the semester, we used it, chapter 7. Okay. Also, sometimes they're going to talk about the margin of error. When they talk about the margin of error, they're only talking about this part right here. Everything to the right of the plus or minus. That's what's called the margin of error. Margin of error means kind of cushion in which I could have made a mistake. Okay, not a mistake, but sampling variability, things like that. Okay, so if they talk about margin of error, they're only talking about this guy right here, right? Whatever I add and subtract. Okay, so we did all of these. We did all of these calculations now. Let's go to calculations. Our point estimate, our p hat was 0.8. Okay, plus or minus. Again, this right here is the margin of error. So this would be considered the margin of error. Okay, that's what we're going to add and then subtract. Okay, so 1.96. Why did we use 1.96 again? Remind me. Exactly. It's a 95% confidence interval. That's the critical value that goes with that. That's the one we're going to use most often. 95% is usually the one they use a lot. Sometimes they'll use a 98, 99, 90 sometimes, but most of the time it's a 95. Okay. We did our calculations and we got 0.7095 to 0.8905. Okay. Because we haven't, exactly right. What do those numbers mean? I have no clue, right? That's why we do a conclusion. Okay. So the last step we didn't cover yesterday was the conclusion. Okay. I've given you a sentence frame for the conclusion. Okay. I've given you a sentence frame, given you two sentence frames. We always do this one time we do a confidence interval. You always draw a conclusion because the numbers don't mean anything until you've concluded them. Okay. So we start out by saying we are blank percent confident. So for this one, it's a 95% confident. We're 95% confident. That's pretty confident. If you're 95% confident about anything, you're pretty confident, right? That the true proportion of, what do you think we're going to put in here? The population parameter, yeah. That's the reason we do that first, is because it's just copy and paste there. Okay, so we did that earlier. That's the first thing we did. Right there. It's literally copy and paste. True proportion of all meals that reach the customer in 1 minute. Let's see, meals that reach the customer in 1 minute is between, that's where our interval goes. So 0.707095 and 0.8905. Okay, so what does that mean? It means I'm 95% confident that whatever the true answer is, whatever the true percent of all the meals at these restaurants that gets to the customer in within a minute is somewhere in between 71% and 89%. That's my interval, right? I'm 95% confident the true answer is somewhere in there. That's what the interval means. Without having done, so you're kind of predicting the future because I haven't kept track of every single meal and the time it gets to the customer. I've only did that for 70, right? They only did that for 70. So based off of that sample, we are making predictions really about the future, about the question. Okay. So I'm 95% confident. That's pretty confident, right? Can't be more than 100% confident that the true proportion of all of the meals that reach the customer in 1 minute for this chain of restaurants is somewhere between 71% and 89%. So somewhere between 71% and 89% of all of the meals get delivered there within 1 minute. Okay? So it's not an exact number, it's an interval, right? It's not like this number here. Why don't they give us one number? Because if I gave you one number, the confidence would go way down. And if you're not confident in something, why do it? Right? It's just a guess. If you're not confident in something, it's just a guess. Well, this isn't a guess. Based off the data, I'm 95% confident, pretty confident that the true answer is somewhere between 0.7095 and 8905. Okay. Um, okay. So that means if I were to do this 100 times, if I were to do this same 5 steps 100 times, 95% of the time would contain the true answer. The true answer would be in the intervals. Okay? If I had different p-hats, so if I took different samples, if I took 100 different samples, my p-hats wouldn't be the same. Some of them might be 0.8, but some of them might be 0.7, some of them might be 0.6, 0.75, 0.62, 0.3, whatever. So if I did this 100 times, 95% of them would contain the true answer. So if the owner wants to be even more confident, they would do another sample. Run this, do another sample. Keep doing multiple samples. The more samples, the best, and that would contain the true answer. Okay? Which we're going to do. We're going to do this tomorrow. Not for this question, but we're going to do something similar tomorrow. Okay? All right, so the last thing is sometimes they'll ask you to interpret a confidence level. Interpret a confidence level. This is not part of a confidence interval. This is not part of the 5 steps. But sometimes they'll ask you to do this extra. This is a sentence frame we use. If we collect a large number of samples using this method, about 95% of the resulting confidence intervals will contain the true, and then do your thing. Okay? That's only when needed. We don't need to do this every single time. Only when asked, you do this. This part, 100% of the time you do it. You don't ever leave this out because it's part of the 5 steps. This guy here, only when asked. Okay. All right. Okay, so now let's look. Before we do a second one, because that's what we're going to do today, we're going to do a second one. I want to ask you these questions. Fill in the blanks. Fill in the blanks here. What do you think goes in the blanks? You have 3 options. Goes up, goes down, stays the same. Goes up, goes down, stays the same. There's an error here. The margin of error should be this guy here. What I said earlier, the margin of error should be this guy here. Let me highlight that. It should be the green stuff. Green is margin of error. All right, so as my confidence level goes up, as I get more and more confident, I'm 80% confident here, 90% confident, 95, 98, 99 is pretty much the highest. Get more and more confident. Oops. What do you think is going to happen to my margin of error? So you think it's going to go down? Decrease. So you think as my confidence level goes up, I'm going to get more and more, I'm going to make less mistakes. So let's think about the pennies. Let's get the pennies out back again. So what is margin of error? What's a definition of margin of error? You guys have seen it before in newspapers and on articles, and you've read about what is another way of saying margin of error? What does that mean? Chance to fail, chance to make a mistake, right? Mistakes. I could be off, right? It's like a buffer, right? So as my confidence level goes up, what's true about the buffer? Gets bigger, gets smaller, stays the same. Makes sense, right? As your confidence level, as you're more confident in guessing the pennies, don't you want more of a buffer? Right? The buffer, the interval, the reason the interval goes this way is because of margin of error. This part here, the green part. The green part is what causes that. So as I get more and more confident, the buffer is going to get wider. So the margin of error will increase. Margin of error is the buffer. So as I get more and more confident, I want a bigger buffer, right? As far as I can go, right? The pennies, if I could guess, if I could be somewhere between 0 and 1,000,000 pennies in here, that's pretty confident. That's a huge margin of error, right? But if you want me to, but if I'm saying there's somewhere between 300 and 400, I'm less confident. Margin of error has gone down. Okay. Another way is just to calculate the numbers. You can calculate the margin of error here. Always calculate it using just the green part. Okay? As the sample size goes up. So as my sample size goes up, what's going to happen to the margin of error? Say what?
Goes down
Why goes down?
because it's in the denominator.
There you
get more, then it becomes more normal, right?
There you go, right?
Variability.
As this guy goes up, what's going to happen to this overall number? It's going to go down, right? So the bigger n is, the smaller margin of error will be. So how do I decrease margin of error? Get a bigger sample size, right? Get a bigger sample size. How do I increase margin of error? Become more confident. Become more confident, okay? Or want a higher confidence level, right? Let's say I'm redoing this problem here. Let's say I'm redoing the restaurant problem. Let me bring up the prompt again. Let's say I'm redoing this problem. What if I were to say, okay, the owner, no, the owner doesn't want to be 95% confident you guys got the right answer. The owner wants to be 99% confident. What's going to happen to my interval? It's going to get way wider, right? It's going to get way wider, almost to a point where it's useless, right? Right now it's about 20, or it's about 19%. There's a 19% interval there, right? From 71-ish to 89, 18, 19. That guy would just get wider and wider, right? That's what happened if I want to become more confident, right? Okay. That's this right here, very common multiple choice question. They'll talk about margin of error. They'll be like, how do I increase margin of error? A, B, C, D, E. How do I decrease margin of error? A, B, C, D, E. What happens if I get a bigger sample size? What happens if my level of confidence goes up? What are the effects of that? Margin of error either goes up or down. Margin of error is going to be affected with either of these two. It's not going to stay the same. Okay. Okay, so let's do the last question. The last question. Okay. All right. This is kind of a question that has some relevance today, in today's time. That's why I chose it. The mutating disease problem. It is believed that the vaccine for a horrible disease has been effective on 62% of its recipients. Okay. Medical research teams have been tracking this horrible disease that has no name. It's not a real disease. It's just no name. Okay. It's not a disease. It's not a real disease. It's just, or they don't name the disease. And this is way before COVID. I picked this question out like 5 years ago. It's probably flu vaccine. Flu vaccine is about 62% effective because the flu vaccine, there's lots of different strains of the flu that go around every year, so they can't be 100% effective, but they're usually about 60 to 70% effective. Okay, so this is not, it has nothing to do with COVID, but it's kind of similar to it. So medical research teams have been tracking this horrible disease and are looking for evidence to see if perhaps the vaccine is now less effective than it used to be. Maybe the disease has evolved, right? Got a different strain, right? Kind of like COVID, even though this is not COVID, you got different strains of COVID. Started with the alpha strain, then the delta strain, now we're in Omicron, and who knows what's going to happen next. It mutates, right? The vaccine is administered to a random sample of 450 adults. Okay? And after following these subjects for a period of 3 months, it was found to be effective in 259 of them. Does this provide evidence that the vaccine has become less effective? Okay. One way we can answer this question is by doing a confidence interval. Okay. Now, let's highlight some stuff. Let's pull some stuff. What are the important things that we need to know? Definitely sample of 450. That's definitely important. We're going to label that as n equals 450. Very good. What else can we pull from there? 259. What does 259 have to do with anything?
The true proportion of the sample that was effective.
So what can we call that? 259 out of 450, and that's p hat. Good. That's from the sample. Very good. So as a decimal, what do you got? 5.755 repeating. Okay, perfect. Good. I like that so far. What else? 62%. That's a definitely important. Here's a trick question. What the heck is 62%? P. There you go.
What was the trick? You?
What's that? Say what? Say it again.
I thought you said it was a trick question. What was the trick?
Yeah, it was a trick question because I was wanting to see if you got P from that.
What else would we get? Mu?
You could get a lot of different things from it. 62%. What does 62% represent?
Well, it's the P. To the proportion that is effective.
There you go. That's you just did our next step.
Huh? What?
Anything else that's important?
I don't think anything else is important.
All right, good enough. So let's do a confidence. Oh, actually, what's missing? Confidence level. Yeah, confidence level. So if they don't give you a confidence level, always go back. Don't pick one. Go to 95. Use a 95% confidence interval.
Is that like expected?
It's like a default.
Oh, okay.
It's default. 95% is a default confidence interval. Now, that being said, almost every time they'll tell you what percentage they want to use. This question is the one random one where they don't tell you. On a test or a quiz, I'm going to tell you. I'm not going to have you guys guess. All right. All right. So P equals. Say it again, Aldrin. What'd you say? True proportion
True proportion of people that the vaccine is out.
of.
True proportion of people that the vaccine worked on.
There you go.
Oh.
For which vaccine was effective? Effective meaning they didn't get the disease. I'm guessing because effectiveness you can have different definitions of effectiveness. You can say they just plain don't get the disease, or you can say if they do get the disease, they don't get like too sick, right? If you get the flu shot, you can still get the flu, but you just won't be in bed for 3 days, right? You'll be able to. Every year I get the flu shot, and I'll get the flu, but I can still come to school. I'm not bedridden, right? That could be effective as well. Okay, so that's what they mean by effective. All right, next one. Next step. Test statistic. Another word for test statistic is formula. Label each section. I forgot to label this section. Label each section so it's easy to follow. So whoever's reading your paper knows exactly what is what. Set test statistic, or you can just say formula. We're going to use the one on the board, which is the one in your notes. P hat plus or minus Z critical times the square root of P1 minus P over N. The reason this is important is because it identifies the procedures we're using. We're using a one sample confidence interval for proportions.
That means there's like multiple sample proportions.
Not in this chapter.
Not yet.
There'll be two sample, but it's very similar to that. Okay. Next one is conditions assumptions. Okay, so this is proportions. So simple random sample. How did they get the 450 people? Stated. Next one is 10% condition. So that's 10%. Oops. n equals, n is less than or equal to 10% of big N. So little n is 450. We know that already because we labeled it earlier. They don't give us a picture for big N. So who does big N represent? There you go. All people who receive the vaccination. All vaccinated people. All vaxxed people. Third one is normality. Okay, we check that by saying n times p is greater than 10, and n times 1 minus p is greater than or equal to 10. So what was p in this case? There you go. Yeah, that's the one you're going to use. If you don't have p, use p hat. But in this case, we have p. So let's use it. .62, it's going to be a decimal, but I believe it's going to be
279.
Yep. 279 is bigger than 10. 171. Okay. Alrighty, calculations now. So p hat in our case was 0.576 plus or minus. What are we going to use for z critical? 1.96. Very good. We're going to use p again for this guy. Divided by n, which is, what is n? 450, thank you. Okay, so I'm going to show you guys a shortcut to get that. Calculators, get your calculators handy. It'll take me a second because I got to get my calculator out of the loaded up. So you've done it the other way, right? We've done this before. So you don't necessarily need to do it this way. So you don't need a calculator to do it, but I'll show you a trick. I'll show you not a trick, it's a shortcut. I'll show you a shortcut to get the interval using your calculator. Again, you don't need this because we can crunch these numbers without a fancy calculator. Just any calculator with square roots can do that stuff, right? But I will show you since we have some time. So the first thing you're going to do is you're going to go to a button we haven't used before. It's no, the first, not yet. Stat. Go to stat. We've done the stat before. Go to stat. We're going to go to a function we've never used before. So when you hit stat, we've used edit and calc, right? We've never used tests. Now we're going to use tests a lot this semester. Now we're going to scroll down to which one we want. There's a lot of tests and there's a lot of intervals. So let's look. If you keep scrolling, there's even more. There you go. We want the ones that say interval. We want the ones that say proportion. So we don't want tests. So the first 6 options are tests. Z interval, that's close, but is there one that's better? Anything that says 2, we don't want that. There you go. A, letter A, right? 1 proportion, Z interval. Okay. N. N in this case is 450. What do you think X is going to be? Not 0.62, you're close. Not p hat. What is X going to be? There you go. The top number of p hat. The top number of p hat. 450 was the lowest number, lower number. The top number in p hat, which was 259. How confident do we want to be? 95% confident. Hit calculate. There's your interval. And it gives you p hat. So if you didn't already have it, boom, there you go. So let's write that down. It's just a quicker way of doing the math that we were going to do anyway. It's helpful on multiple choice where you don't need to show your work. Multiple choice, it's helpful if you need the interval, just to go boom, 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 you got it, right? Free response, though, you need to show your work. So if it's a free response question, I need to see all of the steps. Everything we've done on paper, I need to see. It's just a quicker way of getting your interval.
Can we just like show the equation like that?
Yes. This is exactly what I need to see right here. Okay. I only need to see, okay, so if you show me this, how do I know as a grader if you crunched it by hand, by actually, not by hand, but, regular using scientific calculator, or if you actually use the shortcut? I don't know, because you showed me exactly the math you did and you gave me the answer, right? So I need to see this. This is what I need to see exactly on this page right here for calculations on a free response question, okay? Or homework. Last thing, conclusion. What the heck does that interval mean? Okay. So when you're first doing confidence intervals, stick to the sentence frame I gave you. Stick to the sentence frame. You'll do enough when we take tests, you'll know it, right? But for right now, you've only wrote one conclusion, so I don't expect you to have it memorized. So we're just going to fill this in. We are blank % confident that the true proportion of blank is between blank and blank. We are 95% confident that the true proportion of, go back to your population parameter. You've written it before, just copy it again. True proportion of people for which vaccine was effective. Proportion of people for which vaccine was effective is between 0.529. Yeah, you can. 89 and 0.62122. Done with the confidence interval. Here's my question. We didn't answer the question though. Let's go back to the question. Does this provide evidence that it's less effective?
Yes.
Why?
Because our conclusion is the interval is less than the true proportion.
Okay, so they said it's 62% effective.
We're saying it's
Is 62% inside that interval?
Yes, but like on the very end.
Exactly, right? The probability is it's going to be lower, right? But if you're calling someone a liar, we have to have enough evidence. And if there is a possibility, we can't say they're wrong. So we say we do not have enough evidence. That's not enough because it's within the interval.
Oh, but it's really slow.
I know. I agree with you. It's on the high end, right? It's very close to being over, right? It's not probable. There you go. I would say that. You could say that. You could say, although not probable, I don't have enough evidence to dismiss their claim. Because 6-2 is within the interval.
Not probable, but it is possible.
Okay. Does this provide evidence? No, it does not. And why? Because 0.62 is within the interval. I didn't write it down because I ran out of space, but this is important. Why is there not enough evidence? Because 0.62 is not within is within the confidence interval. Barely, but it's still there. Okay, that's how you answer the question. If 0.62 wasn't in the interval, then I would say, yes, I have enough evidence to say they're wrong. They have to be wrong. But because it's in there, I can't say they're wrong. Okay? All right, tomorrow I'm gonna assign an assignment today. It won't be due till Thursday, but tomorrow we're gonna do a little activity with confidence intervals. It'll give you a better idea of what they are and how to use them and understanding them. But yeah, so it'll be in the book, in the textbook. Okay.
Wait, are we reading our textbook?
Nope. No, your homework that I assign will be in the textbook, as always.